Now, Unit 1. First unit is DC circuits. First unit is DC circuits. Now we are going to define some electrical definitions, basic electrical definitions. Okay, first one is electric current, voltage, battery, conductors, insulators, semiconductors, dielectrics, resistors, inductors, capacitors, electric field and magnetic field, electric power, energy, DC power and AC power. So these terms we are going to define in this session. Okay, let's go to the topic. Okay, first one, electric current. It is represented by I. It is represented by letter I. Okay, what is meant by electric current? Electric current is nothing but it is the rate of flow of electrons in a conductor. It is the rate of flow of electrons in the conductor. What is meant by conductor? Conductor is a material or substance which allows the flow of electrons through this. So the flow of electrons, the rate of flow of electrons, or we can say that the rate of flow of electric charge is nothing but electric current. The SI unit of electric current is nothing but ampere. These are the units of electric current in amperes. Now we can say that in any substance there is an atom. In an atom, the main thing is the nucleus. In nucleus there are electrons, protons and neutrons as the molecules. So electrons are the negatively charged particles, neutrons are the neutral particles and protons are the positive charged particles. So due to the movement of that positive charge or negative charge, there is a flow of electric current. See, this electric current is nothing but the rate of flow of electric charge. I equals to dq by dt. dq by dt is nothing but the rate of flow of electric charge q with respect to the time. I equals to dq by dt. In terms of voltage, we can say that electric current I equals to voltage by resistance of that conductor. See in this diagram. In this diagram, we can say that. Okay, see in this diagram, one cell or a battery is connected to a small bulb, electric bulb, through a conductors or wires. So wires are generally made up of conductors, aluminum or copper. See this battery or cell, it is connected to a small bulb and the current from this battery will be flows through this conductor and that will glow the bulb, electric bulb. See the charged particles from the battery that will move from positive terminal of the battery towards the negative terminal. The direction of current flow is from high potential to the low potential. High potential it is represented as positive in the battery. Negative means low potential, low ability of flow of electrons. Or we can say that high potential means high voltage terminal, low potential means low voltage terminal. Now the current will flow from positive terminal of the battery towards the bulb and from bulb to negative terminal of the battery. The direction shown here is nothing but, see, from negative terminal the electrons are flowing. The direction of electric current is taken from positive terminal to negative terminal out of the battery, but the direction of electrons is considered from negative terminal to the positive terminal of the battery. Why? Because see, the conventional direction of the current is assumed as the positive direction to the negative direction before invention of the electrons. Why? Because generally we scientists assumed that from high potential to low potential the electric current will flows. But after this electric current discovered, electrons were discovered and they observed that the flow of electrons is just opposite to the direction of electric current. So whatever may be the direction of current is taken from positive direction to negative generally, since current is due to the positive charged particles and negative charged particles in the semiconductors. But in conductors, These are due to the flow of electrons. So the conventional direction of current is taken from positive terminal to negative terminal of the battery. But the direction of electrons, negatively charged particles, is taken opposite to the direction of electric current. Okay, now let me go to the voltage, electric voltage. It is represented by capital letter V. See, voltage is nothing but it is a force that will drive the electrons or the charge to flow through a circuit or to flow through a conductor. So this is the force that will drive the charge or electrons in a circuit or in a conductor. It is also called, it is the potential difference between 2 points in a conductor or in a circuit. So this potential difference, it allows for the transfer of energy from one circuit to another circuit. See, voltage is nothing but the force that drives the electrons to flow through a circuit. It is nothing but the potential difference between 2 points in a circuit that will allow for the transfer of energy from one point to another point. So voltage, it is measured in terms of volts. These are the units of the voltage, which is defined as, the definition of this volts is nothing but 1 joule of energy per coulomb of charge. 1 joule of energy by coulomb of charge is nothing but volts. Voltage is measured by a meter. It is called voltmeter. Voltmeter will measure the voltage between two terminals of a conductor or any element. So see in this right side in this diagram, see right side in this diagram, there are two tanks are there. Left side one tank, right side one tank. So in these two tanks, let us say left side tank is having a more water and right side tank it is empty one, and let us assume that the water is flowing from left side tank to the right side tank by using a small pipe. Now see, in the left side tank there is a high pressure, and in the right side tank there is a low pressure. How we can say that there is a high pressure and here is a low pressure? Because in the left side tank, see that there is a less air gap in the left side tank. That's why it is having a high pressure, and in the right side tank it is having more air gap. That's why it is having low pressure of the water. So in the left side tank it is having high pressure of the water. In the right side tank it is having low pressure of the water. Now we are transferring the water from high pressure tank to the low pressure tank. Now we can say that this process we can equate to the flow of electric current through a conductor. Suppose here the water we are considering as the electric charge in a conductor. These tanks are nothing but conductor. Now water we can take as a electric charge. Now this flow of water we can consider as the electric current. The flow of water means the flow of electric charge from one point to another point. We can call it as the electric current. Now the pressure, see the pressure of the water, it can be seen as equally as the voltage between two ends of a conductor, because here water pressure will drive the water from first tank to second tank. But in a conductor or a circuit, the force or pressure, electric force or pressure, that is nothing but voltage that will drive the charge from one point to another point in a conductor or circuit. Now in the right side diagram also, see there is a small battery that is connected to a small bulb. This battery having some voltage. There are two terminals written as positive terminal, negative terminal on the battery. Positive terminal is nothing but high potential terminal or high voltage terminal. Negative terminal is nothing but low potential terminal or low voltage terminal. The direction of current is from high potential to the low potential through a conductor. These green lines or red lines are nothing but They are the conductors, wires. They are connected to a bulb. Due to the flow of electric current through this bulb, that bulb will glow because that bulb is having a resistive element tungsten. So whenever electrical energy is supplied to that tungsten resistive element, that will convert electrical energy into heat, so that will glow. So next we'll go to another topic. See, what is the main difference between voltage and current? What is the main difference between voltage and current? See, in the previous part we seen that, okay, this also similar to that one. See, here in the right side there are two pipes. One is large cross section pipe and another one is a small cross section pipe. They are joined together by using a coupler. See, the water is flowing from high cross sectional pipe to the low cross sectional pipe. See, so this we can equate to the electric current through a conductor. Suppose the water is considered as the electric charge and the flow of water is nothing but the electric current, because the flow of electric charge is nothing but electric current. Here water flow is similar to the flow of electric current. Now here water pressure is nothing but the voltage. Now how this water pressure is formed in this two pipes? How this water pressure is formed? Due to the difference in the uh, cross sectionals, and due to the see, first pipe is having large cross section and second pipe is having small cross section. Due to the difference in the two cross sections and due to the difference in their heights also, some pressure, water pressure is formed. This water pressure is similar to the electrical voltage. Next we go to the topic of battery. Now what is it mean by battery? See, battery is a device. It consisting of one or more electrical cells that converts chemical energy into the electrical energy. See, battery is nothing but it is a device consisting of one or more electrical cells that converts chemical energy into the electrical energy. Now, see, in the right side, first one is the symbol of electrical cell, a single cell represented by positive terminal, negative terminal. Positive terminal is having a one vertical line and its length is bigger than the negative terminal line. Positive terminal means high potential, negative terminal means low potential. It is nothing but single cell. Cell means it provide the voltage. In the right side, see, there are two cells combined to form a single one. This is nothing but a battery. Battery is combination of one or more electrical cells. Combination of one or more electrical cells to form a single one. So in the right side one, there are two cells combined each other to form a single one. So just see, every this one is the 1.5 volts, so a single cell. In the right side, there is a 9 volts battery. This is formed by a 6 number portfolio size cells. So this is the 9 volts battery. Now coming to this part, the example of batteries are lead acid battery, nickel cadmium battery, also known as NiCad battery, the lithium ion battery, also known as LiB battery. So in these batteries or cells, there is a electrolyte within the material. There is a electrolyte. Whenever some load is connected to that cell or battery, that electrolyte will be dissociated into positive and negative charged ions, and the current will be flown from that battery to the load. Now these batteries are classified into primary battery and secondary battery. Primary batteries are nothing but non-rechargeable batteries, nothing but use and throw batteries, just like everyday batteries. But in everyday or Duracell also there are rechargeable batteries also, we can call rechargeable batteries as the secondary batteries. Secondary batteries means rechargeable batteries. Okay, application of these batteries are remote controlling torches and wall clocks, flashlights, hearing aids, weight scales. All these things are applications of batteries. So we can also say that battery is an electrochemical device that will convert chemical energy into electrical energy. Next, now go to the conductors. Conductors. What is meant by conductor? Here see, a conductor is nothing but it is a material or substance which allow the flow of electric current through it. Which allow the flow of electric current through it. See, what are the materials that comes under conductor? So these, see, materials that allow the flow of current is nothing but we can call it as conductors. These materials have free electrons in their atoms, allowing them to flow of current easily. See, these conductors having a free electrons in their atoms. So free electrons means, see, in each atom there is a nucleus, and in nucleus positive charge, negative charge, all these are there. But if they are loosely bounded, all these charges are loosely bounded, then free electrons in that nucleus will flow whenever electric current is given. So this conductor will allow the flow of that free electrons whenever current is given. So this conductor will allow the flow of electrons through the conductor. Flow of electrons is nothing but electric current. Now see, for example, metals such as copper and aluminum are the example of conductors due to their high electrical conductivity. So the electrons in the metals are loosely bounded, so there is a more chances of moving the free electrons through the conductor. So that will constitute the electric current in the conductor. See, when a voltage is applied to a conductor, electrons move from one atom to the another, creating an electric current. Conductor materials are used in the manufacturing of the cables, electric cables, and circuits and other electronic components to allow the electric current to pass through it. See, these are the electric cables. These are the insulation. Insulation means this is the material which don't allow the electric current to pass through it. This is the insulation part, and these are the conductors. They will allow the flow of electric current. So these are the conductors. These are the insulation material over the conductor to avoid the shock. In the right side also, see, in the right side also, conductors are copper conductor, aluminum conductor. All these are insulated by the insulating medium. Suppose rubber or paper, all these insulating materials are covering the conductors to avoid electrical shock. Okay, next we go to the another topic called insulators. Insulator, see, insulators. Insulator is a type of material that does not allow the electric current to pass through it due to its high electrical resistance. So insulator is a material or substance which do not allow the flow of electric current through it. Why? Because see, in the insulators, all the charges are tightly bounded. All the charges are tightly bounded. Due to the tightly bounded, so they will block the flow of electrons through it. They will block the flow of electric current through it. Example of insulators are air can be used as insulator, and mica and glass, paper, porcelain, wood, ceramic, rubber. All these are used as the insulators to avoid electric shock. To avoid electric shock, we use insulators. So these are used, see, due to the high electrical resistance. So insulators having high electrical resistance, they will block the flow of electric current. So they are used as shock-proof substance. So the insulators are used for protection against electric shocks in manufacturing of the electric cables or manufacturing of insulators on the electric poles. Next, semiconductors. Semiconductors are the materials having conductivity in between conductors and insulators. So semiconductors are the electronic components. These are the materials or substance having conductivity, means the ability of allowing the current to pass through it. Conductivity is nothing but ability of a material to pass the electric current through it. The conductivity of the semiconductors is in between conductors and insulators. Conductors will allow the electric current to pass through it, and insulators will totally block the flow of electric current. So in between these conductors and insulators, there is a middle property known as semiconductors, means they will allow the flow of electric current partially. See, the example of semiconductors are silicon, germanium, gallium, arsenide, etc. See, the conductivity of semiconductors can be increased by adding some impurities. Some impurities means these are the chemical substance. Some impurity in the pure semiconductor material called doping. So the some chemical substance, addition of some chemical substance or chemical compound materials to the semiconducting materials to increase the conductivity. We can call this addition as the doping. Doping. We can increase the conductivity of semiconductors by adding some chemical substance or some metals. We can call these metals as the impurities. Okay, application of the semiconductors. Semiconductors are commonly used in manufacturing of the solid state electronic devices. See, solid state electronic devices, we can call it as SSD. See, SSDs, these are used as storage devices in the computers. And these semiconductors are also used in electronic components like manufacturing of diodes, PN junction diodes, transistors, all these are examples. Now we go to the next topic, that is, see some examples of conductors, semiconductors, insulators. Insulators, they will totally block the flow of electric current and they will used as the shockproof materials. Example, rubber gloves, wood, ceramic. All these are example of insulators. Semiconductors are, we can say that they will allow the flow of electric current partially. So resistors can be taken as the semiconductors because resistors, they will oppose the flow of electrons, but partially they will allow the flow of electricity. And conductors, wires, copper, aluminum wires, and metals are also used as the conductors. Next, see dielectrics. What are meant by dielectric? See here, dielectrics are these are generally insulating materials, but they are also store the electric charge. They are generally insulating materials, but they will also store the electric charge whenever some voltage is applied to the dielectric. See, dielectrics. When dielectrics are placed in an electric field is nothing but whenever some electric voltage is applied to the dielectrics, what happens? Practically no current flows in the dielectrics because their nature is insulating property. Because unlike metals, means unlike conductors, dielectrics having tightly bounded, means unlike metals, they have no loosely bound. In metals, all the charges are loosely bound. That's why they will allow the flow of electrons, flow of current. But in dielectrics, all the particles are tightly bound. So generally there are no free electrons to move to constitute the current. So instead, electric polarization occurs in the dielectric materials. What is meant by electric polarization? Whenever some voltage is applied to the dielectrics, the positive charges in the dielectrics are moved towards the applied positive potential and negative charges are displaced towards the applied negative potential of the voltage. So there is a there is a slight separation between positive and negative charges in the dielectrics. So there will be voltage is developed in the dielectrics. So they will store the electric charge in the dielectric. See, what is meant by polarization? Polarization is a phenomenon in which an alignment of positive and negative charges takes place within the dielectric. See, whenever some voltage is applied to the dielectrics, the positive charges in the dielectric will move towards the applied high potential and negative charges will move towards the applied negative potential. Then, while they are moving, there is a alignment of the positive and negative charges takes place within the dielectrics. We can call that alignment as the polarization process. Due to that polarization process, some voltage is developed within the dielectrics. So dielectrics will store the electric charge. Some voltage is developed in the dielectrics. So now dielectric strength is the maximum voltage a material can withstand before it breaks down and becomes electrically conductive. So here one definition is there, dielectric strength. Dielectric strength of a dielectric material is nothing but it is the maximum voltage that a dielectric can withstand before it breaks down and becomes electrically conductive. See, when we apply some voltage up to some mark, dielectrics won't behave as a conductor. But when we apply more voltage after some time, this dielectrics will be broken down and act as the conductors, because whenever more voltage is applied for a period of time, there will be free electrons are produced in the dielectrics and current will be passing through the dielectrics. So we can say that they are electrically conductive at a certain time. So that applied voltage we can call it as dielectric strength. So dielectric strength is a measure of insulator's electrical strength. Here insulator means dielectric material electric strength. It is expressed in terms of volts per unit thickness. So dielectric strength is expressed in terms of volts per unit thickness. Okay, if you would like to get the full video lectures and assignments and notes, you can buy this course. And thank you.